Welcome to the math class. My dear children, in the last lecture, I explained you about the rational numbers, and we have seen how to convert rational numbers into decimal form and from decimal form to P upon Q form, that is a regular rational numbers. And we have also seen that the decimal forms, there are two types, terminating and non-terminating recurring. So these are the two forms of rational numbers. Now I am going to introduce to you the last form of numbers. These numbers are called irrational numbers. The plain way, if I explain you that what are the irrational numbers, then it will be the numbers which are not rational, they are called irrational. Very simple. By word meaning, irrational means which are not rational. Very simple it is. Okay, let us now understand what is the definition of irrational numbers. A number ace means any number is called irrational number if it cannot be written in the form of P upon Q, where P and Q are integers and Q is not equal to 0. You see that from here this is a definition of rational number, because rational number is in the form of P upon Q, where P and Q are integers, means they may be negative, etc., positive, negative, even 0. But the condition is that Q should not be 0. So the number which cannot be expressed in this form is called irrational number. Did you understand? Now there is one more definition, and it will make very clear the meaning of irrational number in your mind. So let us see. A number whose decimal form, see it properly, whose decimal form is non-terminating. Up to here it is same for rational also. A number whose decimal form is non-terminating and non-recurring. This is the important thing here. This one is non-recurring, means non-repeating. So both non-terminating and non-repeating or non-recurring. Then that number is called irrational number. Now you know that what is the square root of or under root of 4? It be plus or minus 2. Under root of 9 is plus or minus 3. You see that 4 is a natural number and 2 is integer. So you can say that 4 is rational number and 2 is also rational number. 9 is rational number, 3 is rational number. Now what about root 5? Root 5 cannot be expressed in this form. It will be in a decimal form. I have written here. So these type of roots, it may be third root, fourth root, fifth root. You can have fourth root of 2. This will be irrational number. Root 5, it will be irrational number. So examples here are written: root 2, root 3, root 5, root 10, minus root 7, minus root 11, and one decimal form I have taken here: 0.10110111, then 1, then 0, 4 times 1 now. 4 times 1 and then 0 and so on. So this is irrational number. Now here I have written some decimal forms. Root 2. Now in the next lecture or when we resume the classes, I will explain you how to get this decimal form, because it is a very long topic and it needs a lot of explanation. You must have done already. We can get the decimal form by division methods. So root 2, if you go on calculator or if you go on computer, you can get the many numbers. It is not never ending decimal forms. So this form is non-terminating. Root 2 is equal to 1.4142136 and so on. Root 3 is 1.732002058081 and so on. Root 5 is equal to 2.2360679 etc. Now pi, pi is the constant. This is called constant. Pi is constant. This constant is the ratio of pi is equal to circumference of the circle and upon its diameter. So pi is equal to C upon D. You must have studied in class 8. Now this pi can be written as 22 upon 7. This is the this 22 upon 7, you will see that this is in the P upon Q form. This is the only question which can be written, or this can be written in this form, and its decimal value is 3.1415926. So Pythagoreans were the first to give the value of pi, and Aryabhat in 400 BC this value was given. Pi value was given by Aryabhat also. He gave 3.1416, up to 4 digits he could give. So these are the irrational numbers, okay? And now real numbers. This is that all kinds of number, all numbers are included. All the rationals, rational numbers, and irrationals means irrational number, these numbers together are called real numbers. And all the real numbers can be shown on the number line. You know how to show rational numbers, and in my next lecture I am going to show you how to represent these irrational numbers on the number line. So open the textbook and go through it and see, read this. It will make your concept clear. Okay, for today I am ending this here only, and tomorrow we'll continue in the next lecture. So this is lecture number 6. Okay, thank you very much.